Albert Einstein's quantum theory of light. The quantum theory of light was proposed by Albert Einstein. It states that light travels in bundles of energy, and each bundle is known as a photon. Each photon carries a quantity of energy equal to the product of the frequency of vibration of that photon and Planck's constant. Now, there are many different theories involved in making Albert Einstein's theory. Firstly, we have the corpusculary theory. This theory was given in the 17th century by Isaac Newton. It states that light emitted by luminous objects consists of tiny particles of matter called corpuscles. This corpuscle, when it hits the surface, each particle is reflected back. The theory states that the velocity of light changes with the change in density of the medium. We have the wave theory. The wave theory was discovered by Christian Hughes in the 17th century. It states that light is emitted in a series of waves that spread out from a light source in all directions. These waves are not affected by gravity. According to this theory, light waves are mechanical and transverse in nature. This theory successfully explains the phenomena of reflection, refraction, interference, and diffraction phenomena of light. Now we have the wave-particle duality of light. The quantum theory of light was given by Albert Einstein, which describes matter and light consists of minute particles that have properties of waves associated with them. Light consists of particles known as photons and matter, and that they're made up of protons, electrons, and neutrons. When all these theories are put together, it can be concluded that light is a particle with wave behavior. So light is dual in nature. Now we have electromagnetism and quantum theory. James Clerk Maxwell formulated the theory that electric and magnetic fields propagate with the speed of light, and concluded that light is an electromagnetic wave. He also predicted the presence of numerous EM waves from the electromagnetic spectrum. Lastly, we have Hughes' principle and the wave theory of light. Contrary to Newton, Dutch mathematician Christian Hughes argued that light is made up of waves that propagate in a perpendicular fashion with respect to the direction of light. He further explained that every point that a luminous disturbance meets turns into a source of the wave itself. A new wave is then determined by the sum of the secondary waves that result from the disturbance. Okay, now we have a bunch of different formulas. So Maxwell's theory of light, you have the question mark, which is frequency, c is the speed of light, and you have this weird looking thing, which is wavelength. Now, we have the Planck's equation, which is E is equal to hc divided by this stick thing. So E is energy of a photon, the h is Planck's constant, the question mark is the frequency of incandescent light, the weird looking thing is wavelength of light, and c is speed of light in a vacuum. The threshold frequency, the circle with the line through it is the threshold energy, the question mark is the threshold frequency, the stick thing is the threshold wavelength. We have more formulas. Photoelectric effect. H is a Planck constant, question mark frequency, W is the work function. And now we have E equals mc squared, which is pretty much the same as the photoelectric effect with the variables. And we have the last formula here, which is pretty much the same as all the other ones. P is momentum. You have the weird stick thing, which is the wavelength, V, velocity, so on and so forth. Now, the significance. The theory which revolutionized our understanding of space and of time and space is based on Einstein's astonishing recognition that light always travels at a constant speed regardless of how fast you are moving when you measure it. Einstein's explorations into the fundamental properties of light also laid the groundwork for his most impressive achievement, the general theory of relativity. The quantum theory of light tells us about how matter and light act as a particle, and also tells us about how light and matter act as a wave. The quantum theory of light was the big reason why quantum mechanics came to be. Now, the future. More than 100 years have passed since the quantum theory of light got introduced to us, but even today his theory is so relevant that many modern day discoveries that and inventions are found to be from his idea, or from his theory. So we have such things as wave optics. It's a branch of science from the quantum theory of light that deals with diffraction, interference, and polarization of light. We have LCD, liquid crystal displays, which is basically TVs, calculators, digital clocks, monitors, stuff like that. Hologram technology, which is still something that we're working on today, but his theory is a big reason why we've gotten so far. And lastly, and also the quantum theory of light is also used to explain the occurrence of various phenomena such as photolysis, X-ray diffraction, bioluminescence, and etc. The bibliography, and thank you for listening to my presentation.